Alright, for volume of revolution, I will just write down the integral for calculating these things, and I'll leave the actual calculation up to you because the calculation is quite complicated when you actually do them. If you want to know whether you did it correctly or not, you may use something like Wolfram Alpha or other websites to calculate the definite integral, and you can compare the calculation with yours. It's not that different from what the definite integrals that we have been doing so far, so you shouldn't have any problem once we figure out the definite integral. Okay, so let's look at this. You have a region enclosed by 2 times radical x. Remember, radical x has this graph, and I made it rather going up high because 2 is multiplied. So let's say this is 2 times radical x. And then the x-axis and also x equals to 2. So that's the region. And it's asking to rotate this around the x-axis so that you get a 3-dimensional object that looks like a bowl, except that this is a solid bowl. It's all filled in. And what you have to know is that this volume can be thought as sum of all these small disks, right? If you chop it this way. So chopped it this way, you're going to get all these disks whose cross section will be circles, and circle area is pi r squared, right? So pi r squared is the area of the circles that you get, and the thickness in this picture, the thickness would be like this, right? So this would be dx. So the formula for finding the volume would be integrating from 0 to 2, 0 to 2 of this pi r squared. And we're still not done yet because we have to figure out what r would be. And r is, in this picture, if you cut any cross section, this part right here will be what's going to be rotated to form a circle. So that's your r. And that's exactly the value of this function, right? So this r would be 2 radical x. So you end up saying for a, it's integral from 0 to 2 of pi times 2 radical x, that's my r, squared dx. Okay, this is not that hard, so let me quickly calculate. Squaring this would be times 4 times x, and 4 pi is a constant multiple, so you can pull it outside, and you integrate dx, which is x dx, which is 1/2 x squared times 4 pi. And you plug in 2 and 0. When you plug in 2, 2 squared is 4. 4 divided by 2 is 2. So you have 4 pi times 2, which is 8 pi. Now, let's try b. This time it's the same region as before, so from 0 to 2, but you're rotating around the y-axis. So what you get is, you get something like a cylinder, except that it's caved in, and inside that there looks like something like a horn. And for this, you need to cut it horizontally in order to get these donut-shaped things. We call them washers because it's flat, and it's like a donut but it's flat. And you're trying to add up these washers, which have very thin thickness, and this time the thickness is this direction, so it's dy. Okay. And because these are 2 concentric circles, if I call the capital R as as the big circle. Pi r squared will be the area of the big circle, and you have to subtract away the small circle, so it's pi small r squared, and that's why you have to multiply by dy to give a small thickness to it, and then you add this from a to b. That's how you get the integral for the volume. This is volume when you have to chop the object horizontally. So it's very important for you to look at the graph and decide which one it should be. It's either dx or dy, and if you can't figure out whether it's dy or dx, there's no hope in trying to figure out the actual integral. Okay, but here we're in pretty good hands. Now we have to think about the cross section that would generate this circle. So if we have the big radius and the small radius, what are these? Well, think about a generic cross section. So if you take this horizontal section and then you call this as A and then B and then C, we're going to decide, we're going to assume that the height is y. See, because we're integrating by y, everything in here, these has to be functions of y, or else it's not ready for calculation. Okay, you have to make them as functions of y. Okay, so we're looking for functions of y, and therefore we want to express these coordinates as at level y. So it's a cross section at level y, which means that A, B, C will all have y as their y coordinates, and it's really the x coordinates that we don't know. Well, for two of them we do know. Here's 0, so A is right above 0, so 0 must be the x coordinates of A. And C, it's right above 2, and it's always 2, right? In any cross section, it's always 2. So it's always 2. What's not so clear is, what is this B? And if your y shrinks, this B becomes closer to the y-axis, right? So its x-coordinate changes according to the changes in y. So this is actually the hardest part to figure out. And the hint is that this curve has a formula. This curve has the formula that y is equal to 2 radical x. And therefore, if you solve this for y, so let's see, let's solve this for y. If I divide both sides by 2, and then square both sides, I get x equal to y squared over 4, right? And that's what it is. At level y, this x coordinate will be y squared over 4. That's the thing that you have to plug in. You have to put here in order to figure out the big radius and the small radius. This is actually the hardest part. Okay, now once you have this, imagine this being actually rotated around the y-axis. What's happening? You get the small radius being AB, right? So R would be AB, and capital R would be AC, right? So the big radius will be from, see, A is the center, so and C is the farthest point, so AC would be the big radius, right? And therefore now you have to figure out the distance between A and B and distance between A and C. And since they have the same height at y, the only thing that really matters is like the difference between the x coordinates, right? So from A to B, from 0 to y squared over 4, how do you get distance between 2 points on the number line? If you have, say, -1 to 2, what's the distance? You do 2 minus -1, and you get 3 as the distance, right? The same deal here. You subtract the two numbers, and that's your radius. And in the same way, here it's 2 to 0, right? So it's 2 minus 0, so it's 2. And therefore, now we can plug these into this formula, and we're almost done. Therefore, the volume is the integral. And the y goes from where to where? The least value of y is 0, and when you plug in 2, this point up here is 2 comma 2 radical 2, right? So 2 radical 2 is the maximum value of y. So 0 to 2 radical 2 of pi times capital R squared, so it's 2 squared, minus pi times y squared over 4 squared dy. Okay, so if you integrate this, which is clearly something that's doable, it's just long and complicated, it's doable, so this will be the volume that you get. Okay, so please try to do this integration. Maybe it's not too bad, but try it and see if you can get the answer that matches with some other online software for integration. Okay, part C, let's see. This time it's still this y equals to 2 radical x, and here's 2. This is the region, except that now you're rotating this around y equals to negative 1. So y equals to negative 1 is this horizontal line, right? So if you rotate this around here, because there's a distance between this two, when you rotate this around, on this side it's going to be like this, right? And in 3 dimensions it'll be like this, with the middle one being completely empty. So there will be a cylindrical hole in the middle, so it's like a bowl, but in the middle there's a cylindrical hole. Okay, so that's what's happening. Okay, so again, this you get circles if you cut it this way. So you want to cut it, you want to cut this way, but since the axis, the center of rotation is at -1, your small r and big R would be from this distance. Okay, so you have to know this distance and that distance, and let's name them. I'll call this A, and then B and C, and because we're okay, so first we have to think about the thickness. Thickness is, if you cut it this way, the thickness will be this way, so it must be dx, right? Horizontal means it's a small change in dx. So we want dx, and because these are 2 circles, concentric circles, pi big R squared minus pi small r squared is what we have to integrate. And we have to integrate from x goes from 0 to 2, so dx means I have to write the x values here. X goes from 0 to 2. In the previous example, it was dy, right? So I had to go from 0 to 2 radical 2 because those were the values of y. Here, x goes from 0 to 2, so I put 0 to 2. So that's what we have to do, and the only thing that we have to figure out is the capital R and small r. And if you look at how this is going to rotate around this center axis and create the circle, we see that R would be AB, whereas capital R would be AC, right? Okay, so that means we definitely need to find out the coordinates for that, and because we need dx, everything should be in terms of x, so we're going to assume that the point that you're cutting is right here is your x, which means all of the coordinates here should be x. Okay, so if it was dy, then you would have y, y, y. If it's dx, then you would have x, x, x. And then think about the y coordinates. So y coordinates is the only thing that we don't know. But for a and b, that's easy. Here's -1, so the y coordinate for a is -1. B is right on the x-axis, so the y coordinate for that is 0. And then what's the y coordinate for C? Well, C is the one that changes with respect to x. As x gets closer to 0, c shrinks down to 0, right? So what's the relationship between the height y and the x position if you were to change this slices? And realizing that this has a equation which is y equals to 2 radical x, that immediately tells us that this thing here should be, let's see, put some room there. This should be 2 radical x. Okay. All right. So now what do we do? From a to b, the y coordinates are it goes from -1 to 0. That's just 1 apart, right? So 0 minus -1, so that's just 1. Whereas AC would be from here to there, so it's 2 radical x minus -1, which is 2 radical x plus 1. And there we have it. We have the small r and big R. Therefore, this would be integration from 0 to 2, pi times 2 square root of x plus 1 squared minus pi times, this would be 2, it will be 2, no, it will just be 1, right? Small r is 1, so 1 squared dx. Done. So that's the answer for the volume. Of course, you still have to integrate this. To integrate this, you have to expand this. As if you expand this, this will be 4x plus 4 radical x plus 1, and subtracting 1 will give you that. So you will end up having to integrate this 4 pi integration from 0 to 2 of x plus x to the 1/2 power. That would be the way you get the answer. Okay. Now let's do another challenging one. How about the region enclosed by y equals to x squared and y equals to 2x? Now if you set them equal to each other, x squared minus 2x equal to 0, so x minus 2 equal to 0. So when x is 0 and 2, they meet. So at 0, they're both 0. If you plug in 2, they both become 4, so 2, 4. Therefore, the region enclosed will be this area, right? And we want to rotate this around the y-axis. So we're going to get something like a bowl outside, but inside there's a cone that's taken out. So that's basically the idea. And to get circles, you would need to divide this, cut it horizontally, so that these will be thin washers whose thickness would be dy, right? So we put dy. Y goes from here's 0 and here's 2, 4. So y value, the least y value is 0, the maximum y value is 4, and we have to do pi big R squared minus pi small r squared. Okay, once again we assume that since this is dy, we do a horizontal slice at level y, and we call this point as A, and then B, and then C, so that we have A, B, C, their y coordinates are y, okay, because you have dy, it should be y, 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 and then A is right above 0, so this would be 0, and C is not right above 0. If it's C is at C, this would be 2, but eventually it gets closer and closer to 0 as your level y changes. See, I put a generic y, meaning that this line can go up or down. So the closer this line goes down, it will be getting closer to the 0. So unfortunately, B and C both change with respect to y. So they both change. So what do we do? Well, we look at the equation of each. First, this one is y equals to 2x. That's the line, right? So we can solve for x and get y over 2. And we see that the equation for this line is y over 2. So this b would be going over, like moving over this line, and because that's y over 2, we will put y over 2 there. Whereas c would be moving over this parabola, right? But what is that? Parabola is y equals to x squared. So x is equal to square root of y. I didn't put minus because the c is only on the right side, so it's never minus. So we see that for c, the x coordinate will be square root of y. And now we are ready to write down what small r and big R is. Small r would be a to b, right? And from a to b, it's y over 2 minus 0, so it's just y over 2. Big R would be a to c, in which case it's square root of y minus 0, so it's square root of y. And these go into here, so now we can write down the answer. So let's see. Let's say this is integration from 0 to 4 of pi times square root of y squared minus pi times y over 2 squared dy. Alright, this is not too bad. Let's actually just do the computation. I can factor out the pi outside. Constant multiple can be brought outside. And then square root of y squared is just y, whereas y squared over 4 is what you get for the second one. So it's 1/4 y squared. And that's y integrates to 1/2 y squared, whereas y squared integrates to y cubed and 1/3, so it's minus 1 over 12 1/3. And then you plug in 4 and 0. So when you plug in 4, 4 squared is 16, 16 divided by 2 is 8. 4 cubed is 64, divided by 12, that will be 16 over 3. So that's pi times 24 over 3 minus 16 over 3, which ends up being 8 over 3 pi. So that's the answer for this one.